Hey guys, this is Mr. Millings, and in this video we are going to learn how to balance a chemical equation. Now, in an earlier video we learned how to write unbalanced chemical equations, and we learned about the different parts of a chemical equation, how everything on the left hand side of this arrow here are going to be the reactants, and everything on the right hand side of this arrow are going to be the products. So we have reactants over here, we have products over here, and what you need to know about a chemical equation is this: whatever you start with on the reactant side, you must finish with on the product side. For example, if we take a look on the left-hand side of this arrow, we have hydrogen and oxygen, and we have hydrogen and oxygen on the right-hand side of this arrow. Okay, so whatever we start with, whatever elements we're starting with on the left-hand side of this arrow, we must finish with. Also, the exact number of each atom on both sides of this little arrow right here must equal each other. If we take a look right now, we have two hydrogens on the left, there are two hydrogens on the right, so they do equal each other. However, if you take a look right here, we have two oxygens on the left and we only have one oxygen on the right, so our chemical equation is unbalanced. And the way that we balance a chemical equation is by placing a coefficient in front of these different substances right here, so that our chemical equation becomes balanced and we have the same number of each atom on both sides of that little arrow. And if you remember from math, if we have a variable like say x, and I place a 2 in front of this, then this little number right here is called a coefficient. Okay, so we can balance a chemical equation by adding coefficients to these different little substances right here, and not by changing these little subscripts right here. So if we take a look at our chemical equation right here, there are two elements in this chemical equation. There are hydrogen and oxygen, and if we take a look as it sits right now, on the reactant side we have two hydrogens and we have two oxygens, and on the product side we have two hydrogens and only one oxygen. So we can see that our chemical equation is unbalanced. So what we need to do is we need to go through here and balance our chemical equation by adding coefficients. And I suggest that you use a pencil with an eraser when you're doing these types of problems, because a lot of times it's trial and error and you're going to have to erase at some point in the process. So let's go ahead here. We have two oxygens over here and two over here, so they're now balanced. Our issue is with the oxygen right here, right? With the oxygen, we have two over here and only one over here. However, if I come and put a 2 right here, I now have two oxygens on the product side, and I now have two oxygens on the reactant side. They now balance each other, but if we take a look, 2 times 2 is 4 hydrogens now on the product side, and I only have 2 on the reactant side. So I have to come over here and place a coefficient of 2, because 2 times 2 is 4 hydrogens. So if we take a look now, our chemical equation is balanced. On the reactant side we have 4 hydrogens, on the product side we have 4 hydrogens. On the on the reactant side we have 2 oxygens, and on the product side we have 2 oxygens. Let's take a look at this example right here. If we take a look at our chemical equation, we've got iron in this and we have oxygen in this, and as it sits right now we have 1 iron on the reactant side and we have 2 irons on the product side. We have 2 oxygens on the reactant side and we have 3 oxygens on the product side. So if we take a look, our chemical equation is unbalanced, and if we take a look at these oxygens, we have 2 here and 3 here. So what do both 2 and 3 go into? That is going to be 6, right? It is going to be a 6. So if I put a 2 right here, I'll end up with my 6 oxygens now over here. However, if we take a look right here, I also have 4 irons. And because I have 6 oxygens here, I'm going to put a 3 right here, and 3 times 2 is 6 oxygens on the reactant side. So if we take a look, our oxygens are now balanced, but our irons are not. 2 times 2 is 4 irons. I will have to put a coefficient of 4 right here, and now our chemical equation is balanced. Let's take a look at this example. If we take a look, there's only oxygen in here. As it sits right now, there's 2 on the reactant side and 3 on the product side. So you guessed it, what do 2 and 3 both go into? What is the lowest common multiple of 2 and 3? Well, it's going to be a 6, right? So if I put a 2 here, that's going to give me 6 oxygens. 2 times 3 is 6. And if I put a 3 here, 3 times 2 is 6. And so now our chemical equation is balanced. Let's take a look at this example. In this example, we have potassium, we have chlorine, and we have oxygen. And as it sits right now, we have 1 potassium on the reactant side, 1 on the product side, 1 chlorine on the reactant side, 1 on the product side, and we have 3 oxygens here on the reactant side and 2 on the product side. So if we take a look at these oxygens, once again, what is the lowest common multiple of 3 and 2? Well, that is going to be a 6. So if I put a 3 right here, I end up with 3 times 2 is 6 oxygens. And if I put a 2 right here, 2 times 3 is 6 oxygens. So they are now balanced. However, if we take a look now, we have 2 potassiums and 2 chlorines on the left. And I only have 1 of potassium and 1 chlorine on the product side. So I'm going to have to come over here and put a 2 here. And now there are 2 potassiums and 2 chlorines on the product side. Alright, so those are some of the easier type of balancing chemical equation problems. Let's take a look at some medium level balancing equations. Okay, let's take a look at some of these more medium types of balancing chemical equations. If we take a look at this first example here, we have 4 different elements. It looks like we have iron, we have chlorine, we have magnesium, and we have oxygen. And on the reactant side, we have 1 iron, we have 3 chlorines, we have 1 magnesium, and 1 oxygen. And on the product side, if we take a look, we're going to have 2 irons, we're going to have 2 chlorines. If we take a look, we're going to have 1 magnesium and we're going to have 3 oxygens. So our chemical equation is unbalanced. And so if we take a look right away, we're going to notice that we have 3 chlorines and 2 chlorines over here. So the lowest common multiple of 2 and 3 is going to be 6. So if I put a 3 here and a 2 here, let's see what's going to happen now. I've got 6 chlorines on the reactant side now. And 3 times 2 is 6 chlorines on the product side. If we take a look now, I've got 2 irons over here on the reactant side, and I have 2 irons on the product side, so those now are balanced as well. Let's take a look at the magnesiums now. I have 3 magnesiums on the product side, and if I put a 3 right here, I'm going to have 3 magnesiums on the reactant side. Those are now balanced. And if we take a look, by putting a 3 right here, I now have 3 oxygens on the reactant side and 3 oxygens on the product side. So our chemical equation is now going to be balanced. Let's take a look at this example right here. If we take a look, we have nitrogen, we have hydrogen, and we have fluorine in our chemical equation. And if we take a look on the reactant side, we have 1 nitrogen, we have 3 hydrogens, and 2 fluorines. And on the product side, we have 2 nitrogens, we have 4 hydrogens, and we have 4 fluorines. So our chemical equation is unbalanced. And so if we take a look right away, we see that we have 4 hydrogens here and 3 here. So what is the lowest common multiple of 3 and 4? That is going to be 12. So if I put a 3 right here and a 4 right here, let's see what happens. I now have 12 hydrogens on the reactant side. I now have 3 times 4 is 12 hydrogens on the product side. And so now those are balanced. If we take a look also, I have 4 nitrogens on the left-hand side now. And I have 3 nitrogens here and 1 here, which makes 4 nitrogens on the product side. So the only thing now that we have to balance are the fluorine atoms. And if we take a look on the product side, we have 3 fluorines here, plus the 3 here makes 6 fluorines now. On the product side, I only have 2 here, but if I put a 3 right here, 3 times 2 is now 6. So now our chemical equation is going to be balanced. Let's take a look at this next one. All right, let's take a look at this one. In this one here, we have lithium, hydrogen, phosphorus, and oxygen. Lithium, hydrogen, phosphorus, and oxygen. And on the reactant side, we have 1 lithium, we have 3 hydrogens, we have 1 phosphorus, and we have 4 oxygens. And on the product side, we have 3 lithiums, we have 2 hydrogens, we have 1 phosphorus, and we have 4 oxygens. So our chemical equation is unbalanced. The first thing that we should probably take a look at are these hydrogens. There are 3 over here, there are 2 over here. The lowest common multiple of both these numbers is 6. So if I put a 3 right here and a 2 right here, I'm now going to have 6 hydrogens on the left-hand side, and I'm going to have 6 hydrogens on the right-hand side. So those are now balanced. If we take a look, I now have 2 phosphorus on the reactant side. And if I put a 2 right here, I now have 2 phosphorus on the product side. So now these 2 elements are balanced. Let's take a look. I now have 6 lithiums on the product side. And so if I put a 6 right here, I now have 6 lithiums on the reactant side. And so now our chemical equation appears to be, nope, I totally forgot. Look at this. We have 2 times 4 is 8 oxygens over here on the reactant side, and we have 2 times 4 is 8 oxygens on the product side. So our chemical equation is now balanced. Let's take a look at this last one down here. This last one here looks a little tricky, but it's actually not. Let's take a look. There are hydrogen atoms, there are chlorine atoms, there are manganese atoms, and there are oxygen atoms in this chemical equation. And if we count these here, we have 1 hydrogen on the reactant side, 1 chlorine, 1 manganese, and 2 oxygens. And if we take a look on the product side, we have, let's see here, we have 2 hydrogens. We have got 4 chlorines, 2 here and 2 here for 4 chlorines. We have 1 manganese, and we have 1 oxygen. So our chemical equation is not balanced. And so right away you can see that you have 4 chlorines on the product side, and you only have 1 on the reactant side. So if we place a 4 right here, our chlorines now become balanced. We have 4 here, and we have 4 over here. And let's see what else now. We now have 4 hydrogens on the left-hand side of this little arrow here. So now we have 4 over here, and if I put a 2 right here, I now have 4 on the product side, 4 hydrogens on the product side. And so now if we take a look, this is also going to give us 2 oxygens on the product side, and our chemical equation is now balanced. All right, so this one looked difficult, but it really wasn't. So there is some medium balancing. Let's take a look now at some balancing chemical equations where you have oxygen as the reactant. In this set of example problems, whenever you have O2, or oftentimes that you have O2 all by itself on the reactant side, it's going to present a little problem. So let's take a look at a couple of examples, or a few examples where we have O2 or oxygen gas all by itself on the reactant side of the chemical equation. Or let's take a look at some combustion reactions. In this problem right here, we have carbon, we have hydrogen and oxygen. And if we take a look, we have 1 carbon atom on the reactant side, we have 4 hydrogens on the reactant side, and we have 2 oxygens on the reactant side. And on the product side here, we have 1 carbon, we have 2 hydrogens, and we have 3 oxygens. So our chemical equation is not balanced. So whenever you have O2 on the reactant side all by itself, I recommend balancing it last. Balance the oxygens last and balance everything else first. So right away we see we have 4 hydrogens on the left-hand side, only 2 here. So let's go ahead and put a coefficient of 2 right here. That now gives us 4 hydrogens on the product side, and now the hydrogens are balanced. The carbons are now balanced. But let's take a look at these oxygens. If we take a look at these oxygens right here, we have 2 oxygens here, and now we have 2 oxygens over here as well. So that's 4 oxygens on the product side. Only 2 over here. So this is an easy one. We're going to go ahead and put a 2 here and change this to a 4, because now we have 4 on the reactant side as well. And so our chemical equation is now balanced. But let's take a look at this one right here. Once again, we have a chemical equation where we're dealing with carbon, hydrogen, and oxygen. And if we take a look, we have 2 carbons, we have 6 hydrogens, and we have 2 oxygens on the reactant side. And on the product side, we have 1 carbon, we have 2 hydrogens, and we have 3 oxygens on our product side. So let's go ahead and balance these oxygens last. We have 2 carbons here. If I put a 2 here, I now have 2 carbons on the product side, and those are balanced. If we take a look, we have 6 hydrogens on the reactant side. If I put a 3 right here, I now have 6 hydrogens on the product side. So now those are balanced. But let's take a look at what happens. We now have 2 times 4, or 2 times 2 is 4 oxygens, plus the 3 here is 7 oxygens on the product side, and we only have 2 over here. So what number times 2 is going to give us 7? Well, that's going to be 3.5, but these have to be whole numbers. These coefficients here have to be whole numbers. They cannot be decimals. So how can we write this as a whole number? Well, what is another way that we can write 3.5? That's going to be 7 over 2. Right? 7 over 2 is 3.5, and 3.5 times 2 is 7 oxygens, which will now balance this chemical equation. And so what we'll have to do now is multiply all the coefficients here by 2 to get rid of this little fraction right here. Okay, so if we do that, if we put a 2 right here, and if I multiply this by 2, this just becomes a 7. I can get rid of this right here and turn this into a 4. I can get rid of this right here and turn this into a 6. And now my chemical equation should be balanced. Take a look. I have 4 carbons on the left. I have 4 carbons on the right now. If we take a look at the hydrogens, 2 times 6 is 12 hydrogens. 6 times 2 is 12 hydrogens. So now those are balanced as well. And if we take a look at the oxygen, 7 times 2 is 14 on the left. And 4 times 2 is 8. Plus the 6 here is 14 on the right. So our oxygens are now balanced. Okay, so one final little step sometimes, whenever you have oxygen all by itself on one side, or on the reactant side, or the product side for that matter. Let's take a look at this example. Once again, we are dealing with carbon, hydrogen, oxygen, and sulfur. If we take a look, we have 4 carbon atoms. On the reactant side, we have 10 hydrogens. On the reactant side, we have 2 oxygens, and we have 1 sulfur. And on the product side, right now, we have 1 carbon, we have 2 hydrogens, we have, let's count these up, we have 2 oxygens plus 1 here is 3 plus 2 here is 5 oxygens. And if we take a look, we have 1 sulfur on the right. So we have to balance this chemical equation. Okay, so here we go. If we take a look, we have 4 carbons on the left. We now have 4 carbons on the right. Those are now balanced. If we take a look, we have 10 hydrogens on the left, and 5 times 2 is going to give us 10 hydrogens on the right. So now those are balanced. If we take a look at our oxygens, or our sulfurs they're still balanced. If we take a look at our oxygens though, on the product side we have 8 oxygens here, plus the 5 here is 13, plus the 2 here is 15 oxygens on the product side now. And we only have 2 over here. So what number times 2 is going to give us 15? That's going to be 7.5. And what's another way that we can write 7.5? We can write 7.5 as a mixed or an improper fraction, 15 over 2. And now to get rid of this 15 over 2, I'm going to multiply every single one of these coefficients by 2. If I do that, I'll end up with a 2 right here. This will be 15. I'm going to turn this into an 8. I'm going to turn this into a 10, and I'm going to turn this into a 2, and our chemical equation should be balanced. If we take a look now, we have 8 carbons on the reactant side, we have 8 carbons on the product side. If we take a look, we have 20 hydrogens here, we have 20 hydrogens here, so now those are balanced. If we take a look at the oxygens, 15 times 2 is 30. We have 8 times 2 is 16 here, plus the 10 here is 26, and 2 times 2 is 4, and 4 plus 26 is 30 on both sides. And if we take a look at the sulfurs, we have 2 sulfurs on the left and 2 sulfurs on the right. So our chemical equation is now balanced. Let's take a look at another one. And this last one here, this one's a little tricky, so let's take a look. We have nitrogen, oxygen, and hydrogen. And on the reactant side, it looks like we have 1 nitrogen. And let's take a look at the oxygens. We have 5 oxygens. And if we take a look at the hydrogens, there are 2. And on the product side, we only have 1 nitrogen. We have 1 hydrogen, and we have 3 oxygens. So in order to balance this chemical equation right here, if we take a look, there's going to be a 4 right here. We'll have a 2 right here, and we're going to have a 4 right here. In doing so, if we take a look now, we have 4 nitrogens on the left. We have 4 nitrogens on the right. If we take a look on the oxygens, we have 2 times 4 is 8, plus the 2 here is 10, plus the 2 here is 12 oxygens on the reactant side. And 4 times 3 is 12 oxygens on the product side. And if we take a look at the hydrogens, we're going to have 2 times 2 is 4 hydrogens on the reactant side, and on our product side we have 4 hydrogens as well. So our chemical equation is now balanced. Okay, so that is how we're going to go ahead and balance these chemical equations where we have oxygen, or O2, all by itself on the reactant side or product side for that matter. Let's take a look now at just one little rule when we're dealing with balancing chemical equations, and then you can try some problems on your own. So let's take a look at this little rule with balancing chemical equations. It says when balancing a chemical equation, all coefficients in the chemical equation need to be expressed in the simplest whole number ratio of atoms. So if we take a look at this chemical reaction with hydrogen bonding with oxygen to produce water, we can balance this chemical equation an infinite number of ways, right? If we take a look, this top one balances the chemical equation. This one does too, this one does too, this one does too. However, if we take a look, we can factor out a 2 out of each one of these. We can factor out a 3 out of each one of these. We can factor out a 4 out of each one of these coefficients. We can factor out a 6 out of each one of these coefficients. And if we do, we will be left with the correct balancing of this chemical equation, right? It is expressed in the simplest whole number ratios, 2 to 1 to 2. 2 moles of hydrogen to 1, or reacting with 1 mole of oxygen will produce 2 moles of H2O. So an important thing to keep in mind is when you're balancing these chemical equations, make sure that all of the coefficients are expressed in the simplest whole number ratio. If there's something that you can balance or factor out of every single one of those coefficients, then that needs to be done. So let's take a look at some more problems that you can try on your own. And what I recommend you do at this time is pause the video. Go ahead and pause the video and try these out on your own. Go ahead and take the time, take 10-15 minutes to try these out on your own. Write them down on a piece of paper. I'm going to give you guys the answers right now. So how did you do? Did you get them all correct? If so, then you're pretty good at balancing chemical equations. If you like what you see, go ahead and click that little bomb in the bottom right hand corner, and that will subscribe you to my channel. And feel free to leave any comments or questions in the comment section down below. And I really hope you guys found this helpful.